All right, today we're going to move into our linear relationships notes. And so the good news is that this is just another equation and we're just adding a piece to it. So remember when we were finding constant of proportionality where we divide and we find k with the y over x, remember we are just using that equation y equals kx where we're replacing k. So we're kind of doing the exact same thing with slope-intercept form, only now we have a new piece. So now we're going to use y equals mx plus b. So they're very similar, the equations, but the slope-intercept form has an addition piece to it. All right, and so the good news is that m is going to be your slope, and that's going to be alpha, like when you read it, slope-intercept form, the m is first in our equation, and so it's first here in the words too, so that works out. Slope is m, and then we have intercept, which is the b, so intercept is the b, and again, when you read the words, you can clearly see like the b is second, the words are second, so that's really easy to remember. So again, the only added piece is that plus. So let's talk about our different situations. So we're going to scroll over here. So in our two different relationships, our constant of proportionality and our linear relationship, one of them represents a proportional relationship. So that's going to be what we just finished learning, which is constant of proportionality, k. It even says proportional in the wording. And so remember k we found with the y value divided by the x value. And remember our equation was y equals kx. All right, and then our new formula is slope-intercept. And again, the good news is slope is the first word and m is the first letter. And then intercept is the second word and b is the second letter. So they go in order if you ever forget which one is slope and which one is y-intercept. And so this, anytime you have this additional plus piece, that makes it not proportional. Okay, so anytime you have that additional plus on our formula, that is what makes it not proportional. So you can see in our constant of proportionality, we just had the multiplying. There was no addition or subtraction. But in our slope-intercept, we have that addition or subtraction, which makes it not proportional. Okay? So let's look at the examples of the two different types of problems here. How will we know which one is which? How will I know when to use this formula versus when to use this equation formula? So the first one says, Alan earns $12 for each hour he babysits. Well, that one just tells me that K is 12, right? The rate he's earning is $12 per hour. So my equation for this would be y equals 12x, right? Because we just took out the letter K and replaced it with our rate of 12. And our table will follow the rule times 12. So if he works 0 hours, he makes $0. But if he works 1 hour, 1 times 12 is 12, so he'd make 12 bucks. If he works 2 hours, 2 times 12 is 24 bucks. If he works 3 hours, 3 times 12 is 36 bucks. So you can see this proportional relationship where it's just growing by 12 every single time. And again, all proportional relationships start at 0, 0. So we know it's proportional because it's at 0, 0. All right. And then to graph, when we graph it, I would start by graphing my point at 0, 0. And then I would walk 1 and rise 12. I would walk 2 and rise 24. Walk 3 and rise 36. So I'm still making my line, but my line goes through 0, 0. So if it goes through 0, 0, you know the graph is proportional. So what makes something proportional? Well, your equation is just the multiplying piece, or your table goes through 0, 0, or your graph goes through 0, 0. All of these make a proportional relationship. So what makes a non-proportional relationship? So like we talked about, a non-proportional relationship is going to have that plus or minus piece to it. So let's read this example. Alan has $60 and then he earns $12 for each hour he babysits. Well, in this problem, he has 60, and so remember, has is the plus, because that's the thing happening one time. And then he earns $12 for each hour. Each is our multiplying word, so that's going to go with m. So we have 12x, right? That's our multiplying word. And we would say y is our total. So in this case, our equation is different because he starts with that $60. He's starting with money. He's beginning with money. And so if he's beginning with that $60, when you look at our graph, here, we start at 60. We start at 0 hours. He still has $60 because that's how much he started with. That's how much he began with. So a non-proportional relationship will go through 0 something. So in this case, 60. And then if I were to graph these points on my graph here, grab my green, I'm going to walk 0, and then I'm going to rise 60. So my beginning point is no longer at 0, 0. My beginning point is somewhere else along my y-axis. And in this case, 60 is my y-intercept. It's where I'm crossing the y-axis. And so I went 0, 60, and then 1, 72, which would be kind of in the middle there, and then 2, 84, and then 3, 96. So those aren't exact, but they're pretty close. And again, when we connect them, they do not go through 0, 0. So we can see 0, 0 is down here, and they do not go through the origin. And so anything that doesn't go through the origin is considered not proportional. So this line doesn't go through the origin, so it is not proportional. So again, what makes it not proportional? It has the plus b, or the minus. It does not have a 0, 0. It goes through 0 and another point. And it does not start at the origin. It doesn't start at 0, 0. So proportional versus non-proportional. So now that we've kind of gone through that, let's look at our questions. So it says, what kind of equation? So remember, we have two options for equations. We have our proportional, which is y equals kx. And we have our non-proportional, which is y equals mx plus b. So let's see, which one would we use? So the first one says, Carson practices each day to prepare for an upcoming race. He starts the day by running 2 miles and then walking at a rate of 4 miles per hour. So we have a starting point. And remember, when we have a starting point, that is going to be our y equals mx plus b, because that starting point is our plus b. So if he starts with 2 miles, that's our plus. And then the rate, that beautiful keyword rate, is our k, or our m. So 4 miles per hour. Remember, per is our multiplying word. So per would be our m. So we have 4x plus that 2 miles he started with, or he began with. And remember, that all equals y. And then, is this proportional or not proportional? Well, I know it is not proportional because, again, it has the plus. And we know if there's a plus, it is non-proportional. All right, let's try the next one. The next one says, or it doesn't say anything. It says, well, it says stuffed animal collection. The big thing I want to look at is, does it go through 0, 0? It does. And we know any graph that goes through the origin 0, 0 is going to be a proportional relationship. It's going to use the y equals kx formula, and it is going to be proportional because it doesn't have our plus piece to it. All right, let's look at our next table. So when we look at this table, remember, we're looking at the pieces and we're really only caring about the 0 piece. So in this case, our 0 piece is 0, -3. So is that going through 0, 0 like this? No. So this is going to have a y equals mx plus b equation. And it is going to be non-proportional because it doesn't go through 0, 0. It goes through 0, -3, and -3 would be our y-intercept. All right. Our next graph, when we look at it, remember our goal is to just look at 0, 0. So is it going through 0, 0? It is not. So this is also a y equals mx plus b, because I can tell that my plus b here is making that graph move up and crossing at the 3. So again, this is non-proportional because of the plus piece in our equation, or the fact that it goes through the 3 up here instead of the 0, 0 here. And the last one says a family makes homemade pickles. They pack the pickles at a rate of 80 pickles per 5 jars. So in this problem, we have 80 pickles per 5 jars. It says our beautiful word rate, but we do not have any kind of starting point. So we would have a regular old y equals kx equation because they're telling us the rate is 80 per 5, or what would that be, 10, 16? 16 is K. And this would be proportional because there is no plus piece after my equation. There's no beginning point in my words. Okay, so that's proportional, non-proportional, and comparing the old equation to our new equation. Let's go practice.